Hi, my name is Josh, and I'm a master's student in the Cedar Lab. And I'm going to take a minute to talk about some of the research that I've been working on in the lab over the last year regarding genetic algorithm-based poisoning attacks on machine learning models. So I know that was kind of a mouthful. So we're going to break this down and I'm going to give some background information to the various pieces of my research so that way you can understand what it is that I'm doing. So starting with machine learning is basically just utilizing a computer to learn from patterns inherent to data. So you can kind of think of this like solving a series of mathematical functions, right? So we have a lot of equations where we know what the solution is, but we don't know what the variable values are. And some of these variables might be shared among many of the equations. So we can use this set of equations to then determine what these variable values are. And then once we have them, we can then apply those variable values to new equations where we don't know the solution. Just plug in the variable values and we can predict what the solution is going to be. Now, this is kind of an oversimplification of what's happening, but it gives a good analogy so you can understand essentially what's happening with machine learning under the hood. Moving forward from that, we have poisoning attacks. So basically what a poisoning attack is just supplying a machine learning model with data that leads the model to a solution known to be incorrect. Now, this is pretty self-explanatory. If you're training a model from incorrect solutions, then obviously it's not going to be very good at predicting the values of new solutions where we don't know the value. And this is a problem because we actually don't know what the value is, so we can't verify whether or not the model is working correctly or not. And finally, the last piece of this is the genetic algorithm. We're not going to go into too much detail, but all you really need to know about the genetic algorithm is that it's an optimization tool. So it basically just mimics natural selection, which I'm sure it's a concept that you're all familiar with from biology classes, where essentially more fit solutions have a greater probability of survival and less fit solutions have more likelihood to then die out. So this is something that we can kind of mimic on computer architecture, where we have a pool of candidate solutions, but we don't know which ones are the good ones. And we basically run them through a fitness function, and the genetic algorithm will determine which ones are good solutions and then breed those solutions together. And it's kind of just a way to narrow in towards what might be good values to a problem. So, tying this all together, what is the problem that I'm trying to solve with my research? Basically, machine learning is extremely powerful and it's becoming increasingly popular way to automate tasks that would otherwise be very difficult. So one example of this might be a spam filter on your email, right? Every time that you receive an email, it's not going to some person who's going to read through your email and then determine, is this a legitimate email or is this just spam from some company? Not only does that violate a lot of privacy concerns, but there's just no way that that would be humanly possible. However, machine learning can then be used, and we can train a computer to look at the email and learn from instances of spam emails and legitimate emails to determine what are some of the characteristics that will constitute what the email will be, and then we can just automate this task with a computer. With that, though, machine learning is very powerful, but it's also vulnerable to these type of poisoning attacks. And our current methods to detect and handle them are pretty limited. So what I aim to do is to highlight just how easy it is to compromise machine learning model predictions using poison data, which I am generating using the genetic algorithm. So in this regard, I'm kind of acting like the bad guy to show just how easy this is and just how big of a problem it is. And the reason why I'm doing that is to incentivize further research into more robust machine learning models, which are capable of not only detecting the presence of poisoning attacks, but also correcting model learning away from mislearning from these poison instances once they're detected. So just a quick diagram of essentially what I'm doing. In a traditional machine learning model task, we have our labeled data. And this is essentially just data where we know what the solution is. And we feed that into a computer who will learn from it and generate a machine learning model. Now, what I'm doing is I'm intercepting this data before it's being trained on, running it through the genetic algorithm to then add some poison data to it to where we have our poison data set. Now that, when fed into a computer and learned from, will create a poison model. Moving forward from that, we now have some new unseen data where we don't know the solution to this. So traditionally, if we feed it then through our clean model, we can trust that our prediction that we're going to get from it is going to be a pretty good predictor of what the actual value might be. However, if we were to feed this unseen data through a poison model, our prediction would actually not be very good. And what makes this very dangerous is we don't really know whether or not a model is working or not. We just kind of have to trust the prediction value that it's giving us. So if it's giving us bad results, but we're just blindly trusting it, that could lead to some serious issues across many domains. So machine learning is becoming very popular, but with this, this could have some very bad effects. So say you have a machine learning model that's trying to predict whether a computer program is malware or not. Well, if our model isn't very good, it might say, hey, this program's fine to run on your computer, when in reality it's malware and it might end up harming your computer. Or machine learning is being used increasingly in the healthcare field, where we might be able to use it to, say, predict whether or not a tumor is cancerous given various features of a tumor. So if our model isn't very accurate, we might have an issue where we're either going to tell a patient who doesn't have a cancerous tumor, yes, this is cancerous, which could have a bunch of complications, or even worse, we might tell a patient that, no, you're fine, like this isn't a cancerous tumor, when in reality it is, and could put the patient at risk. So you can see that there are a variety of problems with not knowing whether or not we are working from poison data when we are training our models. So I'm not going to dive too much into my early results, but basically I have determined that not only is the genetic algorithm a very easy but effective way of poisoning these models, and hopefully my work will help highlight the need for future innovation into machine learning, so that way we can streamline this process and make it more secure. Machine learning is very powerful, but it is important that we are using it in a way that is also safe, so we're not going to build up this system relying on machine learning just for these sort of attacks to then be able to be performed on them. So yeah, I hope that was interesting and gave you some insight into the kind of projects that we work on within the Cedar Lab.